Hi.
Hi, are you sure this course is just for 2499?
Yes, and you know this is the only course with this expertise across the world.
No way!
Yes way. Don't delay. Enroll now.
Geeks learning together.
Hi.
Hi, are you sure you can prepare for product based companies through this course?
Yes, sitting at home?
No way!
Yes way. Don't delay. Enroll now.
Geeks learning together.
Hi.
Oi! So they give access to their job portal, Geeks for Geeks, for free?
Yes, complimentary with the course.
And you got your job through that?
Me and 15,000 others across the world.
No way!
Oh, yes ways. Don't delay. Enroll now.
Geeks learning together.
Yeah, hello. Am I properly audible and visible? Can someone please confirm in the chat box so that we can quickly start? Very good evening to everyone present here. And those who are with me today, can you please kindly write your name in the chat box to confirm your presence? And then we can very quickly start. We have 11 people with me right now. And I would request everyone to kindly stay connected with me till the very end. We will be discussing two very important concepts related to graph today. Hello, Ashish Singh. How are you? Yeah. Okay. So I'm sharing my screen. Just a minute. Hello, Gaurav Pandey. Welcome. Hello, Aditya. Welcome. Yeah. So I have shared my screen with you all, and the slides of today's session. The link of the slide is already there in the description. And yeah, though this is the Google Jamboard I will be using for today's session. The link is already there in the description as well, which you can refer after the session gets over. Okay. So, yeah, we have 13 people with me right now. So, let us start then. Okay. So, a very good evening to everyone present here. So, let me introduce myself. And before that, this is the session number 8 of uh, Graph and Tree series for interview preparation. Okay, so we started in on December 5th, and this is the eighth session today. We have covered various topics like representation of graph and traversal algorithms like BFS and DFS. We also talked about connected components. We also discussed about multi-source BFS and zero one BFS. We discussed about directed graphs. We discussed about topological sorting. We discussed about Khan's algorithm, and we discussed about other topics related to graph, which you can find in the first 7 sessions. Okay, so today we will be discussing majorly about Dijkstra's algorithm and Bellman Ford algorithm. So today we will be majorly discussing about Dijkstra and Bellman Ford algorithm. Okay, and in the next session we will be taking questions related to these two algorithms. Okay, so so let me introduce myself. My name is Gaurav Kumar Shaw, and I am presently in my third year at IIT Kharagpur. And I'm also a mentor at Geeks for Geeks. Okay, so hello Naikaj, welcome. Hello Aditya, welcome. Hello Gaurav, welcome. So there are two Gauravs in the session today, Gaurav Pandey and Gaurav Lokmani. And in fact, my name is also Gaurav. So Naikaj, welcome. So let us begin then with our discussion. Okay. So the first and the very and before we begin, I would like to tell you about this series. So this will continue for the remainder of the December month, as well in the next month as well, in the January as well. So we will be discussing about all the concepts related to graphs and trees. Okay, so graphs and trees, and I will also be discussing all the famous interview questions which are very frequently asked in interviews. And apart from that, I will be also taking up necessary theory as well, and we'll also do some extra questions as well, practice questions as well. So from next few sessions, I will be discussing taking one, two, or three practice problems, and at the same time giving one or two homework questions as well. So kindly stay with me till the entire session, and by the end of the next month, we will be covering almost everything related that there is to cover in graphs and trees related to interviews. Okay. Yeah, yes, Naika, there are three Gaurav today in this session. Okay, so let us begin then. So the first we are going to study about Dijkstra's algorithm. So can anyone in the chat just summarize what exactly Dijkstra algorithm is? Just a small introduction will work. Anyone? You can just give me a short, brief description about Dijkstra. So Dijkstra, single source shortest path. Okay, let us see then. Did we study anything related to finding shortest path in previous of our sessions? No, right? So yeah, so this is the first time we are studying about how to find the shortest step path. Okay, and Dijkstra's algorithm is one of the most famous algorithm that help us to find the shortest path. So let us look how. Okay, now shortest path between two nodes. Naika is saying about BFS. Okay, yes, BFS is there, right? But the idea of finding shortest path comes from the fact that there is a weight related to every edges. Okay, so this is the first time that we are actually dealing with an algorithm that involves weighted edges. Okay, and that will come have a role to play in it. Okay, so we actually did a problem related to multi-source BFS, sorry, 0 1 BFS, in which there was something called in which we were trying to find the shortest distance, right? If the weight of the edges were either 0 or 1 using 0 1 BFS. So an interesting Geeks for Geeks article is also present. If you just Google up 0 1 BFS, you will get that link. Okay, but this time the question is a bit more formal. Okay, so let us see how to do that. Give me 2 minutes. Yeah. So yeah, so let us begin then. So let us first talk about the yeah. So as you can see, I have drawn a graph on the screen. Okay. So this first of all, what exactly is this graph? So this is an undirected graph, and the second most important point here is that every edge has a weight associated with it. Okay. Now our aim is to find the shortest distance from all the vertex from the sources. Okay. So let us say I have got a source. Okay, and my source is 0. The node number 0 is my source, so this is my source. And I have been asked to find the shortest path from this source from every other node. So basically, if someone is asking you what is the shortest path that I can reach the node number 2 from node number 0, you can say that the shortest path is 4. Because if you directly come from 0 to node number 4, the weight will be 4. So shortest path is 4. But let's say if you are coming in this fashion, from 0 to 1 and then to 2. So the path will require 4 plus 2, which is 6. So path in this, the distance covered in this direction is 6, and in the first way it was 4. So you have to answer basically 4 because 4 is the shortest path. Now this algorithm will basically, after we run this algorithm, we will get the shortest path So after you run this algorithm, you will get the shortest path from 0 to each and every node. You will get a shortest path to 1, to 2, to 3, to 4, and to 5. And we will basically output it in the form of an array. Okay. So how exactly does this algorithm work? Okay. Now we have to know a few more things. Important point here is that all the edge weights should be positive. Okay. So it means that if there is any negative weight, we cannot apply this algorithm. And the second thing is, if there is any negative weight cycle, then also we will not be able to apply this algorithm. In fact, this will give a time limit exceeded error. Can anyone tell me why a negative edge or negative weight cycle will not, Dijkstra will not work in that? Anyone? Can anyone tell me? It will keep decreasing the weights. Okay. So yes. So what happens here is that whenever there is a negative cycle, so Dijkstra algorithm basically works on decreasing. It will try to find the shortest path. So what it will do, it will try to get a condition. It will check that whether there is a better way to reach a particular path than the previously computed way. So if I am able to reach a path by, let's say, a distance of 5, and I find a way that it is able to reach a path by a distance of 3, so we'll update that. But do you know what will happen in case of a negative cycle? What happens here is that since it is a negative cycle, the weight will keep on decreasing, because if the weight is minus 2, initially it took minus 2, in the next iteration it will take minus 4. So minus 4 is less than minus 2. So it will keep on updating, because every time we are traversing that, the weight are actually decreasing. Okay. So this is the intuition behind why it is not possible. We'll discuss this later in this session. Okay. Now first let us look into the concept of what exactly a Dijkstra algorithm. Okay. Now can anyone tell me which data structure we will use in Dijkstra algorithm? Okay. Can anyone tell me? We were using data structure Q in our BFS, and when we tried to do 0 1 BFS, we were using our data structure DQ. Okay, so what data structure we will use to implement Dijkstra's algorithm? Okay, so basically, let me tell you the concept. The concept is something like this. We start from node number 0 and we try to go to every adjacent node of node number 0. We see that there are 2 and 4, 2 and 1. Now, in order to reach node number 1 and 2, the distance required is 4. Now we will compute these distances. Now again we will try to go to the next possible distance. Then we will see that in order to go to 2, we will take distance number 4 plus 2 equal to 6. But also we are seeing that a better way to reach 2 is equal to 4. Okay. So we have to compute this idea. We have to check that whether there is a better way it exists or not using the previously computed distances. Okay. If there is, then we will just, what we will do, we will update it. Okay. So which data structure we will be using? Naikaj and Gaurav are saying priority queue. Yeah. So the answer is priority queue also, as well. So we can implement the same thing using set as well. Okay. But in this session, we will be discussing how to implement using priority queue, because this is more conceptual. Okay. And by using set, you can also do it. But yeah, so that this will be your homework. Okay. So let us look into how we will apply priority queues. Okay. So let us say this is my graph. Okay. So this is my given graph, and if this graph is given, so this graph is given in the form of an adjacency list. So everyone knows the meaning of an adjacency list. Okay, so adjacency list is basically the representation of the graph. Apart from this graph, we are also given a distance array as well. So initially what we have done here is that we have marked all the distances as infinite, okay, which is actually a very large value. So we are marking it with int max, okay, or 118, whatever it is. Okay. So we are putting a very large value inside this distance array. Why? Because Dijkstra's algorithm tries to optimize the distance. What it will do, it will try to decrease the distances at every iteration. It will try to decrease the distances. So if there is a path with a better distance, it will try to update that. And so initially we are putting int max. So that every new distance it will acquire, it will be definitely less than int max, so that we can update. Okay. So that is the reason we are initially putting as int max. We are also taking a priority queue. So what happens in a priority queue is that, and this priority queue is of type min heap. Okay. So what happens in min heap is that in this data structure, the value with the minimum, so whatever data we are putting in it, the minimum value will be on top. Okay. So let's say we are putting a data, let's say we are putting the distance in this priority queue. So whatever distance will have the least value, we will get it on the top. Okay. So this is what happens in priority queue. And priority queue, just like queue, it is also a similar data structure, that is first in last out. Okay. So basically, whatever element who will go inside first will come out last, and whatever element is coming inside last will come out first. But actually, this thing will not be applicable because this will rearrange itself, right? So whatever value the distance is minimum, it will come on the top, and that element will take it out from the top. Okay, and we only have the liberty to take elements from the top. Okay, so I hope everyone understood the concept till here. Any doubts? So if there are no doubts, so let us proceed. So how exactly we will proceed? Let's see. Yeah. So how exactly we'll proceed? Let's see then. So what exactly we do here is that let us talk about the approach. So we are taking priority queue. That is the number one point. The second point is the initial configuration. What exactly will be the initial configuration? The first step is deciding the source node. Since this Dijkstra algorithm will try to find the shortest distance from the source node to every other node. So before we start off the algorithm, we have to decide the source node. So we need to define a source node from which the shortest distance we need to calculate. And in this question that we will do, we will take the node number 0 as our source node. Okay, so source node is done now. Apart from source node, we need to define a priority queue. And this priority queue will contain two variables. Two variables. So basically this priority queue will be of the type pair of int comma int. Okay. So the first parameter of the priority queue will be distance, and the second parameter will be the node number. Okay, I hope everyone got it. So let me write. So the priority queue will be something like this: PQ of int comma int. Okay, so basically this is a pair, and it will be in the form of distance comma node. Okay, so the first parameter will be the distance. The second parameter will be the node. So the distance required to reach that node. Okay, so distance is basically indicating the currently updated value of the shortest distance from the source to the given node. Okay, so if someone is so if I am able to find something as 5 comma 3 in my priority queue, it means that till now, till the position where my algorithm has actually progressed, it will take a distance of 5 units to go to node number 3 from starting node of 0. This is what the distance 5 comma 3 means. And what will happen? I will try to find a better distance. So is there a better distance to reach from node number 0 to node number 3, which is better than 5? If I'm able to find a better distance, I will update that in my distance array and remove that from the priority queue. Okay, so this is how the concept works. Okay, so since we also need a distance array, as I have already told, we will initialize it with large number. But what we will do here is that we will initialize the zeroth index, that is the node number 0, with 0, because the distance from the source node to itself will be going to be 0. So that is the reason we are initializing the zeroth index with 0. Okay, so we are done with the initial configuration. Now let us look how the algorithm will proceed. Okay, so what will happen here is that, okay, till before we proceed to the algorithm, is there any doubts? Naika is saying I can't see anything you write. Okay, you can't see the Google Jamboard. I guess my screen is shared. Yeah, so I was basically describing the processes of what will happen. Okay, so this is what it is. Okay, so let us move to the discussion of the algorithm. Okay, so what happens? The algorithm consists of, the first thing that consists of is that we are going to use the min heap. So that is a priority queue, and then what we will do? we will take a distance array of size v, the number of node it is, and initializing to infinity, which we have already discussed. Initially, we will push the source node into our priority queue with a distance 0. And then for every node at the top of the queue, we pop the element out and look for its adjacent node. If the current reachable distance is better than the previously distance indicated by the distance array, we update the distance and push it into the queue. Okay, so this is how we will proceed. Okay, so let us see how. Let me write it here. There is a glitch in between. Oh, maybe it may be due to network issue. Okay, hello Sumit, welcome. Yeah, so we are basically discussing about Dijkstra algorithm and Bellman Ford algorithm. We will discuss these two algorithms today. So I'm already between the Dijkstra algorithm. You can join the session now. Okay. So what exactly happens here is that, let's say, so inside the priority queue, we will initially push the node number 0 with a distance 0. Okay. So this is what we have initially pushed. Now what we will do, we will try to go across all the adjacent nodes of node number 0. Okay. And then we will try to see what is the distance it takes to reach that node. So let's say this is node number 1, this is node number 2, this is node number 3. And I'm taking a distance of 3 units, this is 5 units, and this is 7 units. So let's say I'm taking these units. So what will I do? After I am able to, what I'm doing here is that I am pushing, now I will push 3 comma 1 into my priority queue. Why 3 comma 1? Because according to this, I am taking a distance of 3 units to go to node number 1. Then I will push 5 comma 2. So I'm able to take a distance of 5 units to go to node number 2. Then I'm taking a distance of 7 comma 3. Okay, so 7 comma 3 means a distance of 7 units to go to node number 3. So these are there in my priority queue. Okay, so now what will I do? I will take the top element. And what will be the top element? The top element will basically be the distance with the minimum value. So it will be this one. Okay, so now I will come here. Then I will try to go across all its adjacent element and try to update, try to find the adjacent element. So if I'm able to find a new value, I will put it into my queue. And let's say yeah, sorry, my mic got disconnected maybe in the between. So I am sure I did not discuss much. So yeah. Yeah, so what I was saying is that with the help of the priority queue, we will push the elements inside the priority queue. So let's say what we will do, we will start from this source node and we will try to compute the distances of its adjacent node and accordingly put inside the priority queue and at the same time update the distance array as well. Now what we will do, we will take the top element from the priority queue. The top element will be that element which has a minimum distance. Now what we will do, from that element we will try to go to its adjacent distance. And when we are going to its adjacent distance, we will try to check. So we will try to compute the new value. And if our new value which we are getting is better than the previously computed value which we will get from our distance array, we will update the distance array. And this we will do so until and unless our priority queue is not empty. Okay, when my priority queue becomes empty, it means that I have processed all my nodes that there is to process and I have gotten a minimum distance which can actually be achieved. Okay, so after that we will return our minimum distance array. Okay, so I hope it is clear with everyone. Okay, so I'm sharing the link for the GFG article, GFG problem link. Then we can start solving the problem. Just a minute. Yeah. So I'm putting the link in the description, in the chat box, the description for the next problem. So, okay. So this is the question on the GFG portal that we need to solve. That is implementing Dijkstra's algorithm. Okay. Hello, Nikhil. I guess the link got broken. Maybe. Yeah, maybe the link is getting broken. So what can you do here is that you can just Google implementing Dijkstra's algorithm GFG practice. So you can easily get the link. Okay. So whatever I have just discussed about implementing the concept of Dijkstra, I am going to write the same code. Okay. So this function is basically taking int v, which is the number of nodes. Now it is also taking an adjacency list. So the graph is represented in the form of an adjacency list, and we are also getting a source s. Okay. So while I was discussing, I said that we can easily take the source node number 0 as our source. But in this question, we are actually been given a source s. So we have to take that source only. Okay. So let us see how we will do. Yeah. So here is the code. So the first thing that we have to do is declare a priority queue. Now this priority queue will be of the type of min heap. So the declaration statement is something like this: pair int of int. So we are going to store two values. The first will be the distance and the second will be the node. Now this is how we basically declare a priority queue of min heap type. Then we are going to initialize our distance array. So as everyone knows that we are going to initialize it with a very large number, int max. Okay. So this is done. The next thing is that we have to initialize the first value, that is the 0th index, or the source. Okay. That is that since our source is s, it is not 0. So we will initialize the distance of s equal to 0. And the rest, all the values will be negative. Okay. So this is done. After that, what we will do, we will push that source into our priority queue with a distance 0. Since the source has a distance 0, we will push 0 comma s into our priority queue. Then we will traverse in our while loop. So what we will do, we will take the first value from the top of the priority queue. So the second value will give me the node and the first value will give me the distance. So that is why I am writing pq.top.first for my distance and pq.top.second for my node. And after that, what I am doing, I'm just popping that element. Okay. So now I'm popping that element because now I'm processing that node. Okay. And what will I do? I no longer need that node. So now I will go across all the adjacent elements of my given node under consideration. Now, adjacent of node will give me the adjacency list. So the adjacency list contains two values: the node it is connected to, and the second value is basically the weight. So int v will be it of 0 because this is the adjacency list. So it is it is a vector, and the first element of the vector is the node that it is connected to. So u is connected to v with a weight of w. So v will be it of 0 and w will be it of 1. Now we will check whether the distance computed of the present node. So we are standing on node T and we will see whether the distance computed till the node plus the W that it will take to reach the node IT, node W, node V. Okay, we are standing on U. We are going to and we want to go to V. So the distance that is we will take is equal to distance plus W. We will check whether the this computed value is less than the already stored value in our distance array. If it is less than that already stored value, it means that we have got a much better shortest path. So what we will do? We will update it into our distance array. And we will update it into the distance array. And after we update it into the distance array, we will push it into the priority queue. Why we will push it into the priority queue? Because we have to be perfectly sure that there aren't any other shorter distance that may be possible. Okay, so what will happen? So this is why we will push it into priority queue, and in this case, we have pq.push. We are pushing it. Okay, so after that, what will happen? This while loop runs, and as long as priority queue will become empty, our distance array distance 2 will get connected with all the values. Okay, all the shortest path values, and finally we can return distance 2. Okay, so I hope everyone understood this concept. So let us just submit this problem and check whether it is correct or not. Yeah, so as you can see, all the test cases are passing. So therefore this concept is correct. Okay, so any doubts here till now? Any doubts? Hello Naikaj, hello Sumit, are you there? Hello Nikhil, hello Gaurav. So did you all understood the concept of Dijkstra? Why and how we are going to compute the shortest path from any given source to all the other vertices? Yeah. So the next algorithm we will be discussing is the Bellman Ford algorithm. Okay. Thank you, Sumit. Yeah, you have understood. Thank you, Gaurav. Okay. So the next algorithm we will be discussing is Bellman Ford algorithm. But before that, let us talk about why exactly negative edge cycle was not there. Okay. So does it also work with queue? It works with set, okay, but it actually if you're trying to implement using queue, it will get implemented, but it will get the code will become very yeah it but the code will become very complicated. Okay, the code with priority queue is itself itself a bit complicated, but what we do here is that if we are using set, okay, in that case it will become much easier to implement. Okay, you can just google about how to use using priority queue. Okay, how to use Dijkstra's algorithm using set, using priority queue, using queue in GFG only, and you will get very interesting articles related to it. I wanted to personally discuss the priority queue idea because this is the conceptual part here. Okay, because at every point of time we need to take the shortest, okay, the shortest node, the shortest distance possible from the top of the priority queue. So that is the reason we are doing that. Okay, so yeah, so this is done. And the next important thing is that why negative cycle will not work. So basically what is happening here is that if there are negative edges, the distance array will keep on getting updated because negative value will always become less and lesser and lesser. So that is the reason that negative edges, this algorithm will fail in case of negative weight cycle or negative edges. Okay. Now, for what happens is the next case we will be discussing the Bellman Ford algorithm. And what happens in Bellman Ford algorithm here is that the if there are negative edges or negative cycles are included, then this algorithm will also work in case of Bellman Ford. Okay. So what exactly the advantage of Bellman Ford here is that if there are any negative edges, this will work. Okay, we will always get the shortest path in case of negative edges as well. And if there are any negative cycles, this algorithm will help us in detecting that there are negative cycles or not. Okay, so this algorithm has two advantages. The first one is that it helps us in detecting if there are any negative edge cycle or not, and the second one is that it will help us to find the single source shortest path even if there are negative edges, because both of these conditions were failing in case of Dijkstra's algorithm. So this is where the concept of Bellman-Ford comes in. Okay, so yeah, and the other important point here is that it should be a directed graph. Okay, and the next is that it helps in detecting the negative edge weight cycle. And another important point here is that if it is undirected, okay, so let's say if I'm getting a node something like this, node number 2 is connected to node number 3 by an undirected edge. So what we have to do before we apply Bellman-Ford algorithm, we have to convert this Bellman-Ford algorithm to a directed graph. So what we can do here is that we can do something like this. 2 is connected directly to 3 by a directed edge, and 3 is connected to 2 by a directed edge. Okay, so this is what is happening in we have to basically make this changes before we are applying the Bellman-Ford algorithm. Okay, so yeah, so let's proceed with Bellman-Ford algorithm and let's close the Dijkstra path. Yeah, so let us look into the concept of how we are going to do. Okay, so let us say that this is our given graph. Okay, okay, so let us say that this is our given graph, and what are we seeing here is that we are seeing that there are negative edges also. Okay, and at the same time there, yeah. So just a minute, let me once. Just a minute. Let me check a few things before I begin. Yeah. So yeah. So let us say I have been given this graph. Okay. Now what will I do? So the thing is that in Bellman Ford algorithm, what happens is that we have been given our edges and weight in the form of a vector of vector. Okay. So let me just show you the code. Okay. The question, and let us check the parameters. Okay. So this is the Bellman Ford algorithm. Give me a minute. Yeah. So this is the Bellman Ford algorithm, and you can see that I have been given a vector of vector that basically contains the edges. So this function is a vector of vector which represents the graph. It contains two parts. The first is the source vertex to start the graph traversing graph with, and V is the yeah. So this edges contain something like this. You can see the input. The edges means 0 to 1, 0, 1 and 9. There are three values. So it means that the distance between 0 is connected to 1, a directed edge is there from 0 to 1, and the weight of the directed edge is 9. Okay. So, and also we have been also been given a source. Okay. So that we have to start from that source only. Now we have to find the output will give me the single shortest path from starting from the node number 0, which is the source in this case, to all other nodes. Okay, and this will also work even if there are negative weight cycles, or if there are edges, or if there are hmm. Okay, so how to do that? So the first thing is that this is also similar to Dijkstra's algorithm. Okay, why it is similar? Because we will need a distance array. Okay, because here also we are computing the same thing, distance array. Okay, now what exactly we will do here is that initially we will mark the distance of the source as 0, and the remaining distances will be marked infinite. I hope everyone is with me. Isn't it a cycle undirected? Isn't it is a cycle undirected? Okay, I'm sending the practice link. Just a minute. So this is a practice link. You can just Google up the practice link as well, because in the chat box the link is getting broken mostly. So yeah. So yeah, this is not undirected. So this is connected to something like this. This is connected to here like this. So what exactly do I mean by here is that, uh, yeah. So the most important thing that we do here is that we are relax. We relax all the edges n minus one times. Okay. So the most important definition that is important in understanding the Bellman-Ford algorithm is do you mean by the word relaxation? Now let us see what is written here. It is written that distance of u plus the weight is less than distance of v. Then we will update distance of v. This is exactly same as what we were doing in Dijkstra's algorithm as well. Okay, so if you're standing at node number u, and we want to reach node number v, then we already have computed our distance using the distance array till the distance required to reach node number u. We will add the weight w, and then we will check whether the distance already computed for v, if it is greater than the distance that we are computing mu. If it is greater, what we will do, we will just update it, because the newly computed distance is less than the previously computed distance, and we will update inside our distance array. Okay, but the thing is here, the important part here is that we have to relax n minus one time. Why so? Okay, so let us see why. Okay, so basically what happens here is that we have been given the entire data of this node and its distances in the form of a vector and vector. Okay, so basically what we will do, we will in the first iteration, let us say that we are trying to relax in the first let us do we are trying to relax all the edges in the first iteration. In the first iteration, what we will do, we will check, we will go across all the nodes, and then we will try to check if we will try to update the distance. But what happens here is that we will check whether the distance is already infinity or not. If it is already infinity, then we cannot update. Okay, we have to basically find a value. So what will happen when we are going across all the nodes in the first iteration? Yeah. So when we are going across all the nodes in the first iteration, we will be able to update any one of the nodes. Okay, and the whatever nodes we will update will be used in the next iteration. And after we are completing n minus one iterations, we will be able to get our minimum distances for every nodes. Okay, I hope this makes sense to everyone. Okay, so let us see how we are doing it. Okay, so now let me tell you the Yeah. So let us think in something like this. So in this algorithm, what happens here is that the edges can be given in any order. The intuition is to relax all the edges for n minus 1 times sequentially. Yeah. So let us look into this. Yeah. So what I was saying here is that. So what we will do here is that we will try to consider the graph with distance u, distance v, and the weight w. Okay. So here weight is w2 is basically the weight of the edge, and distance u signifies the shortest distance. And basically the distance array, it will signify the shortest distance to reach node number u if it is found. Okay. And distance v, it may be infinite. It will signify the shortest distance to reach the node we found till now. If the distance is basically a better distance, then we will update. Okay. But what exactly is here is that we will try to minimize the distance to reach every node n minus 1 times in Bellman Ford algorithm. Okay. So the checking condition will be something like this. Yeah. So what will happen here in the checking condition is something like this. See. So what we will do, we will run a loop from I equal to 0 to n minus 1. So basically n minus 1 iterations. And then we will go across all the edges. Okay. So what the u and v and weight w. So we have three values. Then we will check whether the distance u is infinite or not. If it is not infinite and I am able to get a new weight, then we will update that weight. Okay. And when we do this process for n minus 1 time, we will finally get the distance array that is required, which will contain the shortest path, single source shortest path for all the nodes starting from the given source node. Okay. So okay, so this is a concept, and let me just write the code here. So I hope everyone can see the code part. Okay. So what I just explained, I have just implemented it here. That this is the distance array which contains infinity, and initially we are initializing the distance of s as 0 because s is given as the source. After that, what we are doing, we are running a loop till for n minus 1 time. Why n minus 1 time? Because we want to relax all the edges by n minus 1 time. Then we are going across all the edges in my. We have been given a vector of edges. So we are going across all the edges every time. Yeah, we will go across all the edges n minus 1 time. So first we will take the every time we will take the u, v, and the weight w, and we will check whether distance of u is is infinite or not. You can see that when we are traversing for the very first time, if let's say if u is not the source, in that case we will get our distance is infinite, and this updation will not work. Okay, so this updation will only work for only one time when we are trying to update it for the very first in the very first iteration. So after we make sure that this loop runs for n minus 1 time, when it runs for n minus 1 time, what will happen here is that it will automatically give me uh, the minimum distance for every node starting from the source node. Okay. So after the n minus 1 relaxation happen, we will try to relax for one more time. If we are able to relax, it means that if we are able to reach up to that conclusion that this condition is getting true, it means that we have found a better solution. Then we will return minus 1, because in that case there is a negative weight cycle in our graph, and for a negative weight cycle we will not be able to get a minimum distance. So that is the reason we will return minus 1. But if there are no negative weight cycle, and if then we will return the distance array. Okay. So let us submit this problem and see whether it is correct or not. So in case if you have any doubts, you can write in the chat box. Hello Nikals, hello Sumit. Okay, Sumit is Suraj is asking that how to strong DP by tabulation method. I mean, I stuck how to fill that table. Basically, what you can do here is that learn recursion first. Okay, so in order to learn the tabulation method here is that you have to get the idea of recursion properly. Okay, so after you get the idea of recursion properly, and in order to convert recursion to tabulation, there are certain set of rules that you need to follow. Okay, so once you understand that how the recursion idea is working, you can easily get the idea of how to tabulation thing is working, because both the concepts are same. In recursion, what happening is that the computer is creating a recursion stack space, and using the stack space, the data is being stored. But in tabulation, you are already storing it in the form of an external 2D array. Okay, the intuition behind both the ideas remain same. So what you do here is that try to relate the idea of recursion in the tabulation. Then you will be able to understand how to fill that table. Okay. So let us look into the code. Yeah. So as you can see, all the test cases have passed. So therefore, our code is correct. So any doubts till now? Yeah. So the slides for today's session are already given in the description of this live streaming. And we have already discussed Bellman Ford today. We discussed about Dijkstra. We discussed the concept. We discussed why the advantages of Bellman Ford, why exactly Bellman Ford is preferred over Dijkstra in some cases, because in case if there are negative weight cycle, this will help us to detect. Okay. And apart from that, if there are negative edges also, this will help us to find the shortest path in that case also, in which by Dijkstra is was failing. So you guys will have a homework. So what you can take from homework is that how to implement Dijkstra's algorithm by using set. Okay. So we used a priority queue data structure to implement the Dijkstra algorithm, but I want you to implement the same using set data structure. Okay. So in that case, you will also find the articles in GFG related to that. So this will be important. And one more thing. So let me tell you, the students who have joined recently, let me just tell you about the series that we are currently running. We have 17 people, and that's a quite a good amount of audience. So I would request everyone to kindly listen to me. So basically, we will be running this entire series till the end of January, and in the next three sessions, we will be practicing. Okay, so I will pick up very few. I will pick up all the good questions that are very frequently asked in interviews of Amazon, Microsoft, or Google, or all the product-based companies that comes around in college campuses. So all those questions will be related to the topics that we have already covered. Mostly it will be DFS, BFS, and multi-source BFS, and Dijkstra algorithm, Bellman-Ford algorithm, topological sorting. Topological sorting is one of the most important algorithms in graph. Okay, and very frequently these days the questions are coming from that. So in the next three sessions, I will try to discuss a total of 6 problems, two in every sessions. Okay, so 6 problems, and I will also try to give two homework problems as well. So a total of 12 problems you will be able to do by the next three sessions related to graphs. Okay, which are very frequently asked in interviews. So I would request everyone to kindly join those sessions. Okay. So today was a session 8 of graph and tree series for interview preparation, and we will be meeting at 10 p.m. every alternate day. Okay. So maybe the schedule will change a bit because the holiday season are presently coming. So what we will do, I will update. You will automatically find it scheduled in the Geeks for Geeks YouTube channel. Okay. So the schedule for the next session, okay, well in advance of 1 or 2 days before. Okay. And apart from that, I would request everyone, we have 19 people with me right now. I would request all of you to kindly give a like to this live streaming and subscribe to the channel as well. Okay. Because at Geeks for Geeks, I'm a mentor at Geeks for Geeks, and we have planned extremely important content over the next few months related to data structures and algorithms and interview preparations. Okay, so this will be very, very helpful for everyone out there. Okay, so apart from that, so yeah, so this is it for today. Let us meet in the next session. If you have any questions, I am here for a few more minutes. You can ask me. The link for the Google Jamboard, the slides are already present in the description of the chat. You can access from there. Yeah. So how was the session, Naika, Gaurav, Suraj, Sumit? DP for interview preparation, when it will go? DP will come after graph series, maybe after a few days, maybe. Yeah, some other mentor is basically planning to upload to stream for DP, and it will start in a few weeks, in a few some days mostly. Okay, you will get the notification in the Geeks for Geeks practice channel itself. Okay, so that is why I'm asking you to kindly subscribe. Okay, so yeah, so okay, that's very well then. So let us wrap up our session. Very good night to everyone and enjoy your holidays. And Christmas is coming, so happy Christmas for that as well. Okay. And if you're preparing for your upcoming internships and placements, and yeah, so if you are in your second year right now, you will be having your campus internship next year. So this is an extremely good time to start learning topics like graphs and DP and start practicing on lead code and other stuffs. Okay, because this will help you to get an internship in the next internship drive. So yeah, and keep visiting the Geeks for Geeks practice channel as well. This will also prove very useful for your preparations. Okay, so this is it from my side. See you in the next session then. Bye bye. Bye bye.